So this is a mixture problem, and I know there aren't a ton of them in the book, although there'll be for sure one of them on the final. So I made a new worksheet, and here's a video because people kept telling me that that was what really stumped them on the final. So on mixture problems, what you want to do is look for what two variables are talking about. So this says, and I took this right out of the exam bank, so this could be one that you could come across on a final. It says a special treat is made by mixing popcorn, and I'm just going to highlight the important stuff, costing 80 cents a pound, and it's mixed with caramel, costing $2.40 a pound. And then how many pounds of caramel are needed to make 8 pounds mixture that costs $1.40 a pound? So the first thing I want to do is look at my variables. So I'm dealing with, oops, let me change colors. I'm dealing with popcorn, and I'm going to call that P, and I'm dealing with the amount of it, because they already told me the price. I want to know how much, okay? And then I'm also dealing with caramel, and I'm going to call that C, and it's the amount. And technically I should write the amount of popcorn, the amount of caramel, but it's kind of hard to write with this little pen, so I'm just going to leave it like that. Alright, so I want to figure out how can I write two equations out of this so I can use either substitution or elimination to solve it. Well, there's two things that we're talking about. We're talking about how many pounds there are, and we're talking about how much it will cost. So the easiest equation is the pounds, because I know that there's 8 pounds, so that means the amount of popcorn plus the amount of caramel is going to be equal to 8. The other equation has to do with cost, and I know that the popcorn is 80 cents a pound. So if I take 80 cents and multiply it by how much, the amount of popcorn I have in pounds, that'll give me the price for popcorn. And I know that if I add that to the cost that it is per pound for caramel, so that's $2.40 per every pound for the amount, so I multiply it times C, then I know that that's supposed to equal 8 pounds for $1.40. 8 pounds at $1.40 a piece. So that's my other equation. So now that I have two equations, I should be able to set it up and use substitution or elimination. And I'm going to go ahead and use substitution on it. So I'm going to take that equation right there, and I'm going to solve for P. So I'm going to take the C and move it to the other side. So it will say 8 minus C. I'm going to use this 8 minus C, and I'm going to substitute it in where the P is. So I have 0.80 times 8 minus C plus 240 C equals, and I'm going to go ahead and multiply that 8 times $1.40. So I know that those 8 pounds, if it's $1.40 per pound for the 8 pound mixture, then I know that that's going to be $11.20 total. So now I can go ahead and use my distributive property and solve for C. So if I distribute the 80 cents through, I'm going to get 640, and the 640 is coming from the 80 cents times 8. And then the 80 cents times C is going to give me 0.80 C. I still have a plus 240 C, and I still have the equals 1120. Hopefully I can fit all this in. I might have to go to the next screen. I can see now that I can combine these because they're like terms. So really what I have is 640. And if I combine those two, I get $1.60 C, because the 80 cents was minus 80 cents and then the 240 was plus 240. Equals 1120. So let me go to the next screen. So I had 640 plus 160C equals 1120. So now I'm going to go ahead and subtract 640 from each side. I have $1.60 C equals, let's see, 480. I can divide by $1.60. And I can see that C is going to be equal to 3. Well, if C equals 3, remember at the start, I know that C plus P was 8. The amount of caramel and the amount of popcorn should be 8 pounds. So C is going to be 3 pounds. And P, that would make P 5 pounds because I know they have to add up to 8. I can also double check myself by plugging it back into the original equation. So I know the other original equation, I can double check myself. So for sure I know they add up to 8. But also if you remember back at my other equation, it was 80 cents times how many pounds of popcorn, which I'm saying is 5, plus 240 times how many pounds of caramel, which was 3. And I can see if that really does equal 1120. And if it does, then I know I did that problem correctly. So that's one of the problems that's similar to one of the problems that you'll see on the worksheet. And again, I took this right out of the exam bank, so this could be one that you could see on a final. I don't get to make those finals, so I don't even get to see the final until the day you take the final. So let me try a different type. Okay, so here's another one. This one, I think I made this one up to be similar to one on the exam bank, but I don't think it was an exact one that was on there. So this one is similar to some you'll find on your worksheet. So this says Mr. Jones invested a total of $5,000 into 2 simple interest bank accounts. One account paid 3% annual interest, and the other paid 8% annual interest. He earned $225 in interest in 1 year. How much did he invest in each account? So if I take a look at the important things here, I'm going to go and highlight what's important. So he invested $5,000 into 2 simple interest bank accounts. One account paid 3% and the other account paid 8%. He earned $225. And then how much did he invest in each account? So on these kind, I always like to visualize it. So I know that he had $5,000. Let me make that pen a little bit thinner. I know that he has $5,000 and he breaks it up into 2 accounts. So in one account he puts a certain amount of money. In the other account he puts what's left over. So you can call that 500 or 5,000 minus X, because you know that he put all the money, he split it and put it in the 2 accounts, but you don't know how he split it. But if he put X in one account, then the other account has to be the $5,000 minus whatever he put in that first account. So X is going to indicate what he put in that first account. And I'm going to go ahead and label that as 3%. And the second account was 8%. So I know my X is going to be the amount of money at 3% interest. And I know that the 5,000 minus X is going to be the amount of money at 8%. So that'll help me build the equations. So on this one, it's not going to be, I'm not going to use 2 equations and use substitution or elimination. I'm going to go ahead and build an equation based on interest equals principal, principal times the rate times time. So simple interest is going to equal whatever you put into it times the rate times the time. And they're saying that it's just an annual account, so you don't even have to worry about the T in the equation. So I know the interest that he makes, which it said he earned $225. So I know that $225 is going to be the I in this equation. I know that that's going to be equal to the principal times the rate times the time. And like I said, time is 1 year, so 1 times anything is just going to be itself. So I'm just going to ignore that. I know that he's got this account that he put 3% into. So I know that if I want to find the interest off of that account, it's going to be 0.03, because that is 3% in a decimal, times however much he puts into the account, which I said was X. And I know that he has another account that's going to add to this at 8% interest. And I know the amount going into that is the 5,000 take away X. So now I've got an equation that represents both accounts and their interest rates being added together to make 225. So now I can start solving. So I have 0.03x plus, and I'm going to have to use distributive property. So 0.08 times 5,000 is 400. And 0.08 times x is going to give me minus 0.08x. And that's going to be set equal to 225. And now I can see that I have like terms on the same side of the equation, so I'm going to combine those. So 0.03 minus 0.08 is negative 0.05x. Don't worry about the negative right now. Okay, it doesn't mean that he's losing money. What's going to happen is you're going to see when I pull this 400 over to isolate the x, I'm going to have a negative on the other side too. So on this side, I'm going to have negative 175, and on this side, I'm going to have negative 0.05x. So I'm going to move to the next screen. So I'm going to still solve for x. So I'm going to divide by 0.05. Pen's not working very good. Divide by negative 0.05. Negative 175 divided by negative 0.05 is going to give me a positive 3,500. Now remember, we said that he had $5,000 and he put x in that account and 5,000 minus x in this account. So in one account, he must have put $3,500. So he put $3,500 into the account that was at 3%. And then if I take that 35 and I subtract it from 5,000, I'll get 1,500. So I know he put $1,500 in at the 8%. And I can always plug those numbers back in and see if it really does work that he makes, I don't know what it was at the beginning, $225. I can take this 3,500 times 0.03 and add 1,500 times 0.08 and really see if that does make $225 in interest. And if it does, then I know I did it correctly. Here's the third type, and this has to do with tickets and concerts. And there's a couple of problems like this on the worksheets and on the exam bank. So I have 200 tickets to the school concert were sold. Student tickets were $1.50 and adult tickets were $3.25. The school made $513.50. How many student tickets were sold? I could guess and check and probably figure this out, but that's not what they're going to give you credit for. They're going to be looking to see if you used a formula. If you set it up. So let's take a look at the important things here. So 200 tickets, whoops, there we go. 200 tickets were sold. Let me see if I can highlight the 200. And student tickets are $1.50. Adult tickets are $3.25. And then the school made a total of $513.50. So I want to figure out how could I write two equations where I could use substitution or elimination. So I have two variables going on that are unknown. I have student tickets, and I'm going to call that S, and I don't know how many were sold. So this is going to be the amount of student tickets. Oh, I need to get a new pen. Okay, and maybe I'll say A is going to be the amount of adult tickets. So I know altogether that there were 200 tickets sold. So I know that A plus S has to equal 200. That's my first equation. My second equation has to do with money. I know that adult tickets are $3.50. So I can say that I could take $3.50 times however many adult tickets there are, and if I add that to $1.50 times how many student tickets there are, that should equal the $513.50 that they made. So now that I have two equations, I can either use substitution or elimination. I'm going to go ahead and use substitution. So I'm going to take this equation, I'm going to alter it, and say A is equal to 200 minus S. So now I'm going to go into my equation and I'm going to put that right there where the A is. So I have 350 times 200 minus S plus 150 S, shouldn't have used S's because they look like my 5s, equals 513.50. So now I can see that I'm going to have to use distributive property right here. So 350 times the 200. Okay, wait a minute here. I messed up right here because it's 325 in the story. So let me make this, let me start over right here. So this right here is 325. Sorry about that. Okay. So I'm going to go ahead and plug this in again. So I have 325 times this 200 minus S plus 150 S equals the 513.50. Then I can go ahead and use the distributive property. And that's going to give me 600 minus 3.25S plus 150S, $1.50 S, equals the 513.50. Okay, so I'm going to go to the next page here. So I have, let me clean it up. I have 650 minus 325S plus 150S equals $513.50. So I'm going to go ahead and put the like terms together, and you can see that the like terms are here and here. And so if I put those two together, I have 650 minus 1.75 S equals $513.50. And then I'm going to go ahead and take the 650 over. I'm going to get negative 1.75 S equals negative 136.50. That's a 6. I divide by negative 1.75 on each side. And I'll get S equals 78. So I know there's 78 student tickets. Well, remember at the beginning we said there was 200 tickets altogether. So 200 take away 78 is 122. So I know if there's 78 student tickets, I don't know if I can fit that in there. That says tickets. Then I know that there's 200 or 122 adult tickets. Sorry about how sloppy that is. I really need to get a new pen. But that will give you an idea of how to work those story problems. I know that that has been an issue in the past, and so I've been wanting to make something to help you out if you needed it. So hopefully that will help.